In this video, I'm going to go over the stock and work coordinate system setup and the different operations to machine the first setup for this part, basically machining down to here, or specifically here. We'll have a round piece of, a cylindrical piece of stock that's 1.5 inches in diameter and about 2 inches long to make the total part. So we'll machine all of this. And then for the second side, we'll have to have some soft jaws to precisely hold this section and machine it. So I've already done the cam, and you can see the different operations here. What I'm going to do is just create a new setup and walk you through this. And so first, I'm going to go setup here, and going to basically choose the Z-axis to be up. I can see that the Z-axis is down. One quick way to get it up is just click this and move it up. And then I want to get the stock, though, the right shape. So I'm actually, before I finish this, I'm just going to go to the stock and just say fixed size cylinder. And let's just keep it at 1.5 inches by 2 inches tall. Right now, the part is centered. I think we want the part closer to the top, and so I'm just going to, instead of saying centered, I'm going to say offset from the front, and let's just have an offset of maybe 20 thousandths of an inch. Okay, so I'm going to go OK. I actually do need to go back and set the work coordinate system, so instead of hitting OK, I should go actually back to the setup tab and go here, and we're going to go stock point and just select the top of the stock. So the origin here is at the top with Z upward. You can see that it is not at the top of the model, it is at the top of the stock, and this piece will be held in some type of holder. I'll talk about that later. We have special jaws that can grab onto the bottom. We can also have different methods of holding cylindrical parts. For that, we don't need to worry about right now. It'll just be held down here, and then we're going to machine down to basically the edge of this flange here. Everything that we can reach in one setup from one direction. So from that, I can hit OK. You can name this setup whatever you'd like. I already have a setup 1. Yours is probably going to be defaulted to setup 1. You could call it setup first side, whatever you'd like to call it. So we want to face the top of the part. Sometimes when this is cut on the bandsaw, the stock is not flat and things like that, and so I hesitate just to go directly to a face mill. I'd like to rough it down to just above the surface, and then do one finish pass with a face mill, and that's kind of what I have here. Tool 11 is actually a roughing end mill, and tool 30 is a standard face mill. So I'm just going to go face and go to the tool. I want to find a end mill that tool 11 is a flat roughing end mill, so it's good at taking off a lot of material. Doesn't necessarily leave a great surface finish, but it does remove a lot of material. So we're going to just go select. Basically, we don't need to do anything on the geometry. It's just the stock is already selected. But the depth, I don't want to stop at the model top. I want to stay just a little bit above, maybe 5 or 10 thousandths above the material. And often what I do is I extend the passes and the width just a little bit. So we might go a half inch in each direction, just to make sure that we're facing everything. And then we hit OK. And if you select, you can kind of see that we're just going to go back and forth and take this material off. So even if it's kind of crooked or whatever, it's just taking the material, but not quite getting to the surface. We're above 5 thousandths. So the next, we can just go face again. And now I'm just going to hit tool 30, which is our face mill. It's a big face mill to take off a lot of material. It has several inserts in it. It doesn't look exactly like this. It actually has insert cutters that come and face that. And we do want to go down. The bottom is basically the top of the model. And we can do some pass extensions. Probably not necessary with a pig cutter, but it's always nice to make sure that you get everything off the stock. And then hit OK. And there we go. Basically, it's just going to come down and go back. If we have a lot of material that we're taking off and it's really thick, sometimes on the face, on the roughing end mill, I will go back and adjust how much the step over is, so I'm not taking off too much material each time it winds back and forth. But I think that's it. The next thing that we're going to do is just start taking off some material. I know I want to go and I'm going to select this edge here and basically do an adaptive clearing of all that material. So we're going to go just a 2D adaptive. I'm going to select this edge for the position. The tool, I'm going to go back to tool 11, which is the roughing end mill. And then the depth is basically the selected contours. I could stay above that just slightly and then come back with a standard end mill to leave a better finish. So maybe I'll just stay above that selection by a tiny amount. However, there is a different, before I change that, let me show you a different way to leave that material. I can just have it on the stock to leave. First, we're going to have some radial stock to leave. I think the default is 20 thousandths. I usually leave 10, but we also want to maybe leave a bit on the surface here, so we'll just leave 10 thousandths there. I think the default is 20 and 20. You can probably keep it there as well. I think that's all we're going to need. The helix is built in, so if I hit OK, you can kind of see what it's going to do. Basically wind down, clear out that material. Now we do want to go down deeper, and I do need a separate contour though. Notice how this wall steps in. So I'm just going to go and do another 2D adaptive, go down to here, and use the same tool. We'll go the same selected contours, but the depth, I want to go deeper than what I selected. And let's try, let's first try -1, but we may have to go back. I need to check the cutting, the effective cutting flute length of that end mill. I don't have that memorized, and we need to make sure we don't go too deep, because the distance between here and here, here and here, is 0.380 inches, 380 thousandths. But let's go and look at the actual tool. So if I click here on the tool, let's see, I think I actually need to click here to look at the tool, and right click and go edit, I think, just to look at it. Sorry about that. So we're going to just look at the cutter. The flute length is 1 inch, but the shoulder length is 1 1/8. So we really can't effectively go that deep down. We already have 380 thousandths. So if we go down another, well, let's go another 700 thousandths, or that will be just over 1 inch. Realize we're not using the full flutes, or we're not using the full flute length because we have 1 inch of flute length, but I need to make sure I can clear this with the shoulder before the collet hits. And so basically, let's just go back here and change the depth to, we'll go -0.7, 700 thousandths, -0.7 from that position. Let me hit OK. I'm getting kind of an error, notice, or a warning. I think what happens is the default helix diameter is too large, and so it's not producing that tool path. Let me right click and go show log, and it will say generation warning empty toolpath. So it doesn't say what's wrong, but most likely what's wrong is this helical diameter is too large. So let me change this and make it just something smaller and see if that works. There we go. Okay, the tool will go down there, clear out this material. Now notice I didn't go all the way through, but we can get that depth on the way back. Okay, the next I'm just going to measure from here to here. We have 1 full inch, so we can take off this material with a rougher. I'm just going to go to 2D adaptive, again go down to this depth, and we're going to go and notice I have the selected contours as the depth, which is fine. I'm going to, let's leave a little bit on the radial and the axial. A couple things that I want to do is not go full depth each time. Maybe the maximum step down is a 1/2 inch, so I go down in 2 different steps. So I'll go down here, clean out material, and then go down again. And then I think we may want to change how much material we take out per pass. Let me just hit OK and let's take a look what we're doing. So it's a lot of material that we're taking out each time as we go down. Basically it's trying to take it all in one pass. And so what I'd like to do is looking through how much the optimal load is 150 thousandths. Let's make that something smaller. Let's go maybe 80 thousandths and see what we get here. Basically now it's only taking a maximum of 80 thousandths off per pass, and so it's kind of taking some material here and then going in and taking the rest of the material. Then it will go down and machine this material and then go and do the rest there. So let's take a look at what that looks like so far. We can simulate. So we're doing the roughing, or the roughing on taking material off the top. Okay. And once we've taken that off, we come with the face mill and clean that up. And then when that's done, we wind down in and do the first adaptive, the second adaptive, and then the next thing that we're going to do is come and do the outer part. Notice we're taking materials in 2 steps, and it looks like I have a little bit left at the end that it continues to do. So there we go. Now we have to come back and do a contour to clean all this up, and then there's some other features that we need to take care of. Let's take a look. Let me hit escape to get out of here. Basically we need to put in this little internal retaining ring groove. It's kind of hard to see in the model. Zoom out there. So there's our retaining ring groove back in here. We have this chamfer on the inner, chamfer on the outer, and then we definitely need to get this part cleaned up as well. So I will do that in a subsequent video.